Hi, I'm Tim Dresser, and I TL the Chrome Speed Metrics team. And today I'm going to present to you a couple results of a page load analysis that our team has been doing. There are two primary goals for this talk. The first goal is to convince all of you that doing this kind of lab-based, large-scale performance analysis is worth doing. I think this technique has a lot of potential, and it's much simpler than a lot of the techniques we use to gather data from the wild. We can iterate much faster and get much more specific data. And the second objective for this talk is to actually dig into some data. We're going to be looking at a bunch of graphs we produced showing how page load works in the wild. I'm hoping this will be a bit of a back and forth, so if you've got some insights, feel free to throw up a hand. Deep is going to be running around with a microphone. Yeah, this should not just be me talking, ideally, despite the room that we are in. So this is just a, this is an initial graph. My main goal here is just to kind of show you what data we were gathering. So there were 5 primary metrics we were looking at. First paint, first contentful paint, first meaningful paint, first interactive, and consistently interactive. We don't need to drill too deeply into the definitions of these metrics, but very roughly, first paint is kind of the first time we drew something. It's not just a blank background. Often this is just they painted the background orange or that kind of thing. First contentful paint, we drew some text or an image. First meaningful paint, some crazy heuristic that we think they probably drew something that was probably useful to the user. First interactive is we kind of think that if the user was to interact with the page, we'd probably respond. The page would probably respond relatively quickly. And then consistently interactive, we're pretty confident that the page would respond quickly. And so we've broken this data up by wall clock time data and CPU time. And then we did 2 loads. We did for each page, we loaded the page, and then we loaded it again so the cache is warm. So each of these data points here, there's 10,000 of them representing the 10,000 different sites that we loaded. And even just with this very high-level overview, there's a couple things that should stick out to you, perhaps. One question is, why on earth do we have these lines here? All of these pages which show up as exactly the same for first paint, first contentful paint, etc. And the answer to that is our data set's kind of bad. This is just a sampled version of the previous slide, because if it wasn't sampled, it would take 15 seconds to load. But I can actually dig in and see, here's the URL. I can go to our page set recorded via web page replay, and I can see, oh, this is a 404 page. And so all these sites just have very similar 404 pages, so that line is not so surprising. One other thing that I found kind of interesting about this data, we can see for cold page loads, this line is rock solid. All those 404s loaded in exactly the same amount of time. What's kind of curious is when we reload them, there's a lot more variability, which is kind of the opposite of what I would have thought. I would have expected that our resource loads would introduce more variability than loading things from the cache. But that appears to not be the case. I think there's some more investigation we could do there. Whether or not it's just the way we're measuring the metric is less consistent, I'm not sure, but we should definitely dig in there. So the high-level objective of this analysis, we want to find some bugs, identify some trends, and fix some things. We're also kind of using this to get a better intuition for page load performance. When we're talking about things like loading interventions, for example, we'd have a really good understanding of how page load works in the wild, and we're hopeful this approach will help us gather that insight. And then as the metrics team, we're also looking for cases where our metrics are bad. We've used techniques like this when we're defining metrics, although not necessarily to this scale. And we find it really useful to be able to see, like, are there patterns that show up that shouldn't show up, that kind of thing. So a bit more about our procedure here. We're using the Alexa Top 10K. This page set has some issues. It's mainly landing sites, so you're not going to see things which are behind login screens. In fact, a lot of the top 10K contain login screens. We're loading on Nexus 5 devices, simulating a 3G network. So we're going to see fairly consistent network speeds, but it's not going to actually be super realistic in terms of reproducing what a 3G network does. Warm and cold page loads, and then we've got reasonably detailed main thread attribution, but only main thread attribution. So here, we're breaking down time to consistently interactive, again by wall clock time and CPU time, and then by the cache temperature. This massive purple chunk here is the amount of time we spent blocked on the network. This is a little bit misleading. All this means is the main thread was idle, and there was a resource load pending. So eventually we'd like to go through and take a little bit of a closer look. Are there other threads doing raster, for example, or that kind of thing? But we can dig into this a little bit. I'll get rid of the block.network stuff. Zoom in. So we can kind of see what's contributing in the mean here. It's pretty similar between cold cache and warm cache. And we can see script execution, unsurprisingly, shows up as a pretty big fraction. Very sadly, other shows up as a fairly big fraction. We'll talk about this a little bit more at the end of the talk, but we're definitely looking to address this. Layout is fairly significant, somewhat unsurprisingly again. This resource loading strip includes synchronous XHRs, but not exclusively. I think we should probably break that out. It seems plausible to me that this is dominated by synchronous XHR. And then we've got some style at the bottom. Any questions about this at this point? Or thoughts, things that surprised you? All right, paint. I see it. Do you? Where do you see it? I don't see it. Yeah. It is scrollable, but I'm not seeing paint. So we'll get into this a little bit more going forwards. But the way, I'll just skip ahead for a moment. Okay. So record, I think, does actually show up. Yeah, this brown thing. Yeah, so this tiny little strip here is record. But some of that may also be falling in the other bucket. I'll just pull it up now as we're on the topic. So getting rid of other. One of the problems we're running into here is just people rename traces and then our categorization stops working. When we initially did this work, we weren't getting anything in the layout category whatsoever because somebody renamed the primary layout slice without adjusting the categorization. The good thing is all of you can contribute by categorizing your slices, and it's really, really easy. There's this file called the user-friendly category driver, and it contains a bunch of things that look kind of like this. So composite is the name of the category, and you just list a bunch of slices. Going forwards, I think we need some tests to make sure that we don't break this stuff. But my guess is if paint isn't showing up very big, it's probably just because we haven't categorized all the slices appropriately, and we should do that. Anything else?
File tracing already has this top level something concept. Are you familiar with it? I wonder if it seems similar to this idea.
I believe we're talking about the same thing. This is used throughout Chrome tracing. So the previous graph, we were looking at the mean. In this graph, we're looking across various quantiles. So the legend's a little bit confusing, but the leftmost column here is the bottom 10%, and the rightmost column is the worst, so 90th percentile and higher. This view is kind of hard to read. The view that I prefer looking at is once we've normalized it. So we've just scaled everything, so we're looking at the fraction of time per quantile. So my strong intuition here was that we're going to see a very different fraction of time spent doing each thing for the worst 10% of sites. But that is not really the case, especially if you just look at CPU time everything from the 20th percentile to like the 90th percentile, we see pretty similar behavior. There's no strong difference in the fraction of time spent doing each kind of task. I found this extremely unintuitive. We do see a fairly significant difference in the leftmost column, but that's quite possibly just all those 404 pages that we mentioned earlier. So from the perspective of making loading interventions, for example, I was expecting us to see, we want to be targeting like the 90th percentile, so we're going to be doing something very different than we'd be doing for the median. But it looks like they're actually pretty similar. And you can see here, yeah, script execution is showing up really strongly. So we're talking in the like 30% kind of range. So here we're looking at what's contributing between each of these timestamps. So here we're looking at between navigation to first paint, and then between first paint and first contentful paint, etc. One thing that sticks out right away is the difference between, say, first paint and first contentful paint, or first contentful paint and first meaningful paint. They're pretty similar. Something else is kind of interesting and reflects on the way we've defined first interactive and consistently interactive. We're idle a lot of the time between first interactive and consistently interactive. You also do see some amount of script, but a lot of that time is spent with the main thread idle with network requests outstanding. Yeah. Yep.
That's not like some unexpected resource just keyed off. It's just there's still, we hit interactive, but there's still network requests pending.
Yeah, so all we know is there is at least one network request pending during that time. We don't know that that network request is blocking us from doing anything. And to do that, we'd have to do like some critical path analysis stuff that would be really hard. I think the main thing we should do to address this, two big things. One is split up this blocked on network to state what kind of request we're blocked on. Is it JavaScript or CSS, that kind of thing? And the other is to get some information about what's happening on other threads. So if we're blocked on raster, then the fact that we're blocked on network is probably irrelevant. All right, so this graph looks at the mean per second of what these 10,000 sites were doing. So it's kind of a weird average trace. And you can see a couple interesting trends here. This weird kind of dip where the like leftmost columns were, yeah, I would have expected this to kind of be more smooth. Again, I suspect this dip is because of the 404 pages. Couple of trends I think are interesting here. One is the distribution of layout. So I'm just going to zoom in on the layout here for a second. Between CPU time and, sorry, for CPU time, and then warm versus cold. For CPU time, layout is actually pretty consistent across this page set for cold loads. And it keeps going for a long time, whereas for warm page loads, the layout tends to be kind of front-loaded. This is fairly intuitive, but I found the graphical representation of it kind of interesting. You can see here as idle gets bigger and bigger, pages are idle when they're done loading. So that also makes a fair bit of sense. Any thoughts on this visualization? I feel like there was one or two other things I meant to mention. Yeah, so we already talked a little bit about eliminating other. It would be much appreciated if people contributed to this. I think we also do need a tooling solution. Improving breakdowns. So we already mentioned blocked on network, splitting that up based on the type of resource. Script execute. shows up as a really big chunk a lot of times, and I'm curious to see whether or not we can break that up a little bit more. I know there's a talk happening later on today about speedometer, which I think is talking some about how runtime call stats can be used to analyze those cases. I think we might be able to use runtime call stats here to get some better data. Filtering out 404s would definitely make the data more useful. Hopefully we can get a more representative page set. And I'm definitely interested in any next steps you folks have regarding breakdowns. Just a couple other things that I think would be fun to do sometime. If we categorized each of these sites based on what frameworks they're using, I think that could surface some really interesting insight into how different frameworks behave. There are some existing JavaScript libraries which just identify all the frameworks being loaded by a page, so this should be fairly tractable. Gathering some memory data and correlating that with page load times should be pretty cool. And finally, applying these same techniques but to other things other than just page load. So we could do this for input or for animation. I think we could get a lot of really interesting insights. So in the remaining time, Rob, do you have?
I think more than just filtering 404s, you want to be looking at how useful the page was. So even if it's like an empty page or a very short page that has a few words on it or whatever, it's going to look a lot like a 404. So maybe filtering by user interaction time or something like that, where pages that people spend a lot of time on are more interesting to us than pages that you navigate away from quickly.
Yeah, so my concern with the 404s is that it introduces bias in the data that's not going to be reflective of normal usage. So I think it makes sense that there are pages on the web where people spend little time, and I think that should show up nicely in some distribution, whereas the 404s don't really fit into that distribution as well. I think it makes sense that things that take less time are going to be used less time, but I think that's okay.
Same though, a 404 is like a page that isn't really representative of something you do on the web.
But pages which are used and take little time are different from 404 pages which are intended to not be used. I don't know, we should follow up offline perhaps. Yeah, thanks. Otherwise I have to remember to repeat your question, and that's probably unlikely to happen.
So I was wondering if you also did some measurements with actually loading the same page twice, because then the code cache should kick in. And hopefully script execute should be smaller.
You said loading 3 times?
Yes.
No, we have not. That sounds like something we should perhaps do.
That would be great. We'll be interested in the data.
Yeah, cool. Yeah, we can do that.
So have you done any tests on mobile, or is this all on desktop? I'd love to see the difference between desktop and mobile. So for instance, script execution CPU may be a lot bigger on mobile.
Right. So this was all done on Nexus 5 devices. So it was all done on mobile. We should also repeat this on desktop at some point. I'm trying to remember whether or not the desktop devices we have in our lab that make this easy to run are representative or not. They're probably reasonable. So yeah, we should do that.
Question about blocked-on network. Maybe it'd be useful to go back to one of the earlier graphs.
Sure.
For blocked-on network, does, if I heard you right, does it basically indicate that main thread is idle, but we have outstanding network requests?
Exactly.
And so no specifics on what kind of network request. It's just that there is a network request and main thread is idle at that time.
Yeah. So this is frequently going to be misleading, and we should break it up more.
Okay, and then that's fine. And then idle is main thread is idle and network is also idle.
Yeah, that's correct.
Cool.
Do you know how much of the where there's big bottlenecks maps to things that developers can measure? Could you potentially in this analysis see any places where the page was also listening for performance timing events to try and understand are the things they're watching getting optimized or things like that?
That's an interesting question. So in general, like our performance APIs have a hard time exposing much of this information. The long tasks API is probably the best thing people have for observing script execution, for example. And if you execute scripts for 49 milliseconds over and over and over again, you get no information whatsoever about that as a developer. The long tasks API surfaces tasks which are 50 milliseconds or more. And then there's also things like composite and record and stuff, which we can't really surface due to privacy constraints. So my intuition would be very little of this can web developers really get a good grip on.
One interesting thing to slice by might be, in terms of helping us prioritize exposing more of these numbers, is if we could see on pages where they, can look for this timing, or they actually did register an event, we see that it's like way more optimized. So we say, it seems to have a big impact on performance just surfacing these numbers.
My intuition is that we'll have a massive bias there that will be very hard to get rid of, where for developers which care enough to register performance observers, they probably also follow all the other best practices. But yeah, if we could figure out some way to eliminate that bias, that would be an interesting analysis. Well, Deep is walking over. One thing I just should mention. So this work was done by the Chrome Speed Metrics team. Lots of strong contributions by Deep, who's running around the mic, and also Max did a bunch of work too.
So you hinted earlier that this is main thread reasons, or things that are blocking the main thread.
Yeah.
How do we fit in pages which are interactive in that you can scroll them, and that is the thing that you care to do on the page, but are still loading content, or is that not?
So yeah, this is definitely a good question. Our time to interactivity metrics make the assumption that we care about main thread interactivity, and I think this assumption is fairly reasonable. If I load a web page which has a bunch of textual content and I can scroll it fine, but then when I tap something, the main thread is busy, so the tap doesn't get processed for a long time. That's still frustrating. And I think there are few enough websites where you expect to where there's no expectation of tapping on stuff, that I think this is reasonable. I think in the cases where we are caring about scroll, something like first contentful paint is probably the best proxy we've got.
I think there's a different pain bar on the two, though, right? Because
yes.
It will be some time after you scroll before you tap on something.
Yeah, and our threshold for interactivity is tasks falling underneath 50 milliseconds, which is focused on the tap threshold as opposed to scrolling.
I didn't expect to see the network so high, because a lot of research papers are saying that for mobile, actually, the bottleneck with decent connection speed tend to be CPU. So that's very surprising. I was wondering, could we do a repeat of that experiment on faster connection, maybe 4G on Wi-Fi, see if it changed the deal or not?
Yeah, that's an excellent idea. One note on that is that some of this is biased to this graph, I suppose, isn't biased, but the time to consistently interactive graphs are a little bit biased because our definition does penalize people really heavily for any small amount of CPU. So even a small amount of CPU can cause you to get delayed. And then during those periods of time where you're delayed, you're probably contributing to blocked on network. So I think we should also reproduce this with some other metrics other than consistently interactive.
Yeah, so since blocked on network is kind of dominating these measures, I do wonder if you thought about how to do critical path analysis, and to kind of tell if we could reduce the CPU time, would that make an actual difference in time to interactive?
So there have been a couple efforts regarding critical path analysis. There was one a couple years ago, which I don't know. It feels like, from my impression, real critical path analysis is close enough to impossible that it's not really worth pursuing currently. And then recently, some of the Lighthouse folks started playing around with critical path analysis and have had some reasonably positive results at doing some rough versions of critical path analysis. I guess in summary, I have no idea whether or not that's a good path to follow, but we should be talking about it for sure.
One thing you might consider is when you do breakdown for the network things, for instance, there should be an easy way for you to know if it was random blocking just by looking at the highest priority things or like the type of sub-resource. It would be rough, but like a good start, I think.
Right. One other note on this is the time to interactive metrics. One of the things that needs fixing is we have this network idle heuristic, which pays attention, like right now, it just looks for when there are fewer than 2 outstanding network requests. And we need to teach those metrics a bit more about what resources are pending. And so as we do that, we may also see this shrink a little bit. There's a question over here from Primiano.
Hey, so mostly a random thought that came to my mind right now. Did you try to see if there is any correlation between the breakdowns here and the Blink usage counters, which I think we might have been to trace? As in, like, if you use some certain Blink features, your, I don't know, loading time or image decoding time become more or less dominant in the.
That sounds super fun to play with. That also sounds like it might logically feed into like, hey, we need a feature policy for this feature that correlates with pages taking forever. Yeah, we should look at that. Yeah, here.
Do you know how many of the sites are using service workers, and is there any like integration with service worker with these measurements?
We have no idea, and that's some more follow-up we should do. That would be really interesting to see if there's a strong correlation. Again, it's tricky because of bias. We can't just say, does service worker make sites better or worse, because sites with service worker are more likely to be modern. But yeah, that sounds like fun.
One last question. Oh, and thanks, Steve, for running around. I appreciate that. And thanks for all your contributions on this stuff, too. Is this data and charts available for us to poke at?
Yeah, I'm currently presenting this off of my GitHub, which contains all of the data. So if you go to my GitHub, there's a repository, Chrome page load analysis. And so that contains zips of all the data and all of the R and R markdown that generates these slides.
Awesome, thanks.
Have you considered running a similar analysis on HTTP archive? We currently have Lighthouse reports available for something like 475,000 sites there, which includes like metrics like the time to consistently interactive. You might be able to get some interesting insights there, including all stats.
Yeah, that sounds like a good thing to do. We haven't really thought about it too far, but cool.
So actually, just building on the HTTP archive bit, one of your crazy ideas was to categorize by frameworks. That's something that we're integrating into HTTP archive.
Nice. So you get that for free?
Yep.
Nice.
So you mentioned you wanted to categorize by frameworks to see if there's any interesting, I guess, correlations there. Are you going to be doing anything in terms of actually sites that have large layout costs tend to have ridiculously large amounts of CSS or unused CSS, or are there any other kind of groupings you want to test out?
I think yes, there's a long list of things we would like to do, and we haven't yet kind of come up with a big long list and prioritized it. If you have any ideas, please let me know, and we'll be trying to come up with a big long list and asking people how they think we should be prioritizing that. There's much more investigation we would like to do than we have time to do. But yeah, all of those ideas definitely appreciated. Yeah. Cool. All right. I guess we'll call it there. Definitely let me know if you have ideas and how we can dig into this data more deeply or any insights based on this information. Thanks a lot.